You walk into the room. The air hits you before the heat does. Stale, heavy, sitting on your lungs like a wet cloth. And somewhere in that room right now, you are breathing in things you cannot see. What I am about to show you costs $7. Not 70, not 700. 7, no machine, no plug, no running cost. Once you build this, it works today, next summer, and the summer after that. This method comes from Japanese farming culture, where cooling a space without power was not a comfort. It was a necessity. 4 generations, it worked. And in 30 years of testing it here, in my own American home, it still does. You have probably stood in a small room this summer, a shed, a workshop, a back bedroom with one window, and felt that air, heavy, faintly sour. You crack the window and nothing moves. You point a fan at yourself, and all it does is push the same bad air faster. The commercial solution costs between $300 and $400. Portable air cooler with a built-in purifier filter. Stores carry them in June. They are gone by July. Here is what those companies are selling you. 2 functions: cooling and cleaning. Inside one plastic box you will need to replace in 3 years. What I am going to show you gives you both functions for $7 and lasts indefinitely. By the end of this, you will know exactly how to build it, where to put it, and why it does not stop working. But first, you need to understand what is actually happening in that room, because if you do not understand the 2 mechanisms, you will make the one mistake that ruins the whole build. The air in a sealed or poorly ventilated room is not just hot. It is accumulating. It sits still. It collects fine dust particles, humidity, and airborne compounds off every surface in that space. A workshop collects sawdust and solvent vapor. A shed collects mold spores and soil particulate. A small bedroom with a closed door in August collects everything the body releases through the night. The standard answer is a fan. A fan does not clean air. It does not cool air in any meaningful sense. It moves the same air at higher velocity, and in a room with poor ventilation, it distributes the particulate load more evenly rather than removing it. Commercial units solve this with a refrigerant coil and a filter media stack. The refrigerant costs money to run, the filter costs money to replace. The compressor breaks in 3 to 5 years, and the unit becomes landfill. You have been paying to cool and clean a room with a machine engineered to need you to keep paying. Stay with me. By the end of the next section, you will have both answers. Evaporative cooling is something your skin already knows. When you sweat, moisture on your surface transitions from liquid to vapor. That phase transition absorbs heat. It pulls thermal energy out of the surrounding air mass. The air temperature drops. Japanese farmers in Nagano hung wet grass mats across doorways and window openings for exactly this reason. My father did it with a mat my grandfather wove from dried miscanthus grass. His father did it before him. The mat held moisture. Air passed through. The air that entered the room was 3 to 5 degrees cooler than the air outside. In a room already at 90 degrees, 3 to 5 degrees is the difference between tolerable and unbearable. The second mechanism is adsorption, not absorption, which is one material soaking into another. Adsorption is a surface phenomenon. A material so porous that its internal surface area is enormous, and as air passes across it, particles physically bind to that surface and stay there. The air comes out on the other side cleaner, lighter. These 2 mechanisms, evaporative cooling and adsorption, can be achieved simultaneously with a single material packed to a specific depth, positioned correctly in a room. That is the whole device. But here is where people waste their money. The material you choose determines whether this works or does nothing at all. Buy the wrong version, and there is a wrong version visually nearly identical to the correct one, and you have spent $7 on something that either does nothing or in an enclosed space could make the air worse. I grew up in rural Nagano, Japan. The summers are hot, and the old houses are built around airflow, not machines. My father cooled rooms and managed the air in enclosed spaces the way a careful person manages anything valuable, with attention, simple materials, and nothing wasted. I have lived in the United States for 30 years. I have tested every method I grew up with against the conditions of this climate. Some methods transfer exactly. Some need adjustment. This one transfers exactly. I will not skip the parts that could go wrong. There is one genuine limitation to this build, and I will tell you what it is plainly when we get there. I would rather you trust me than be impressed by me. Every week on this channel, one honest fix for your home and your yard, 30 years of methods, tested by hand, nothing sold to you. If that is useful to you, subscribe and the next one will find you. The correct material is activated charcoal, specifically activated bamboo charcoal or activated coconut shell charcoal. The word activated is the critical one. Activated charcoal is ordinary carbon processed at high temperature in a controlled environment to open up millions of microscopic pores. 1 gram has an internal surface area of roughly 500 square meters. The same gram of ordinary charcoal has almost none. That internal surface is what performs the adsorption. Without it, the material is inert to airborne particles. The wrong material is barbecue charcoal or any charcoal treated with lighter fluid, accelerant, or binding compound. It looks similar in the bag. In some stores, it sits on the same shelf. The difference is that barbecue charcoal is designed to combust, and the compounds in its processing are not safe to move through air you are breathing in an enclosed space. Open backyard. Not an issue. Shed with one window, it is. Now, 3 safety points, and I will not skip them. First, only use food grade or air purification grade activated charcoal. It will say so on the packaging. If the bag does not say activated, it is not the right product. Second, keep the completed device away from children and pets. Not because it is toxic, but because the loose granules are a mess and curious animals will investigate. Third, depth matters. You need between 1 and 2 inches of activated charcoal packed into your container. Less than 1 inch does not give the air enough contact time to adsorb effectively. More than 2 inches restricts airflow below the threshold where evaporative cooling can function. 1 to 2 inches, that is the working range. Activated. Untreated, 1 to 2 inches of depth. Nothing with a coating, binder, or accelerant on the label. Before the full build, in the comments, tell me which room in your house holds the worst air in summer. I read every one. You will need 5 things: a shallow container, a baking pan, a low-sided wooden tray, or a rectangular planter without drainage holes. Activated charcoal, enough to fill it 1 to 2 inches deep. A piece of natural burlap or loosely woven cotton cloth, cut to fit over the top. A small shallow dish of water, and a source of gentle airflow, an open window, a ceiling vent, or a low-speed fan positioned to draw air across the device rather than directly into it. The total cost, if you are buying only the charcoal and using what you already have in the kitchen or garage, is $7. 15 minutes. That is all this takes. Set your container on a flat surface. Pour in the activated charcoal and spread it to an even depth of about 1.5 inches. Lay the burlap or cotton cloth loosely over the top. Do not pack it down. It should rest lightly on the charcoal surface. Its job is to hold moisture on the upper layer, which is your evaporative cooling layer. Set the shallow dish of water beside the container, not on top. Dampen the cloth until it is uniformly moist but not dripping. As air moves across it, water transitions to vapor and the ambient temperature drops. Position the device near your primary airflow source, but not directly in front of it. Needs to pass across the moist cloth and then through the charcoal layer. Near a window with a cross breeze is ideal. A ceiling fan on its lowest setting also works. That is the complete build. $7 if you are buying only the charcoal and using what you already have. Re-dampen the cloth every few hours in dry heat, or every 6 to 8 hours in a more humid climate. You will know it needs water when the surface feels dry and the cooling effect has faded. The evaporative layer lasts indefinitely. Water in, cooling out. No degradation. The adsorption layer is different. Activated charcoal does saturate. In a room with clean air and moderate use, this takes several months. In a workshop with heavy sawdust or humidity, 4 to 6 weeks. You will notice when it is saturated because the air will stop feeling as clean. That is the signal you want. The reset is simple. Spread the charcoal on a tray in direct sunlight for 4 to 6 hours. The heat drives adsorbed particles off the surface and restores the pore structure. In Japan, this practice is called Hi-Zarashi, sun airing, the deliberate return of a material to open light so it can release what it has taken in. My father used it on fermented grain and on bedding and on charcoal filters he kept in the storage room. The sun restores what time and use have loaded. After sun airing, the charcoal goes back in the container and adsorption capacity is substantially restored. Most households can sun air the same batch across an entire season before it needs replacing. This is what the title means by forever. Not that it never needs attention. A garden needs attention. A well-built house needs attention. Means it does not need replacing on a manufacturer's schedule. No filter subscription. No power cord. It keeps working as long as you maintain it, and the maintenance is 4 hours in the sunshine once every few months. Now, the honest limitation. I told you I would name it. This device works well in rooms up to roughly 150 square feet with adequate natural airflow. A small bedroom, a workshop, a shed, a converted garage with a window. In a large open-plan room with no cross-ventilation, one device is not enough. You would need 3 or 4 positioned at different points. The cooling drop is 3 to 5 degrees Fahrenheit under the right conditions, meaningful in a hot room, but not a substitute for mechanical air conditioning on a 105-degree afternoon. For what it is designed to do, cool and clean the air in a small, poorly ventilated space at no running cost, it does exactly what I have told you it does. You walk back into that room, the air does not hit you the same way. It moves. It is 3 degrees cooler than the hallway. The heaviness is gone. $7. No electricity, no filter subscription, no machine that breaks in 3 years and ends up in the landfill. A shallow tray of activated charcoal with a damp cloth across the top, positioned near an open window. That is the whole device. Build it this weekend. Re-dampen the cloth when it dries. Sun air the charcoal when the cleaning effect fades. That is the entire maintenance schedule for a summer of clean, cooler air in a room that was miserable.